Hi, welcome. This is Mark. Today we're going to discuss CPU registers. CPU registers. Register is a memory space to store data. They are the data holding places in the CPU, and they are very fast memory devices. That is why they are at the top in the memory hierarchy. A processor or a CPU has various types of registers, each having specialized functions to perform. Now let's look at various CPU registers commonly used in 16-bit configuration. Because one word is a minimum of 16 bit. The first one is program counter or PC. It holds the memory address of the next instruction to be executed. This register needs only 12 bits because its size is 12 bits only. Next one is the address register or AR. It is used to keep track of the memory locations to which the instruction is addressed. This register is also 12-bit register. When an operand or data is found, it is placed in the address register, and then instruction register IR stores the current instruction to be executed. After fetching an instruction code from the memory, the microprocessor stores it in the instruction register. The instruction is decoded internally by the microprocessor, which then performs the required operation. The word size of the CPU determines the size of the instruction register. For example, 16-bit CPU has a 16-bit instruction register. The working of this three register is very clear in the diagram. Temporary register or TR. It is used to store intermediate results or other temporary data. In basic computer, the input devices can send 8 bits of data to the CPU, and the CPU can send 8 bits of data to output devices using temporary register. The input register, or INTR, is used to hold an 8-bit data sent from an input device. The output register, or OUTR, is used to hold an 8-bit data to be sent to an output device. Data register, or DR. The processor uses the values stored in the data register for its operation. The accumulator. The basic computer has only one general purpose register, which is the accumulator. In the figure, you can see basic computer registers and memory. Following are the list of BC registers or basic computer registers. The first one is DR, or 16-bit register. It's a data register which holds the memory operand. Next one is the AR, or address register. It's 12-bit. It holds the address for memory. AC is 16-bit. It's the accumulator. It's the processor register. IR, or instruction register, it has 16-bit, which holds instruction code. Next one is the PC, or the program counter. It's 12 bits. It holds the address of the instruction. Next one is the TR, or temporary register. It's a 16-bit. It holds temporary data. INTR, or it's an 8-bit input register which holds input character. Finally is the out R. It's an 8-bit output register which holds the output character rather. So this is accumulator. It's a 16-bit register and it holds the result of the ALU operations. These microprocessors have instructions for shifting and rotation the accumulator 1 bit to the right or to the left using the carry flag. The accumulator is typically used for inputting a byte into the CPU from an external device or outputting a byte to an external device from the accumulator. Some microprocessors, such as Motorola 6809, have more than one accumulator. In these microprocessors, the accumulator to be used by the instruction is specified in the OP code or the OP code. Depending on the register section, the microprocessor can be classified either as an accumulator-based or a general-purpose register-based. In an accumulator-based microprocessor, such as the Intel 8085 and Motorola 6809, the data is assumed to be held in a register called the accumulator. All automatic and logic operations are performed using the register as one of the data sources. The result after the operation is stored in the accumulator. 8-bit microprocessors are usually accumulator-based. The general-purpose register-based microprocessor is usually popular with 16-bit, 32-bit, and 64-bit processors. The term general-purpose register comes from the fact that these registers can hold data, memory addresses, and the results of the ALU operations. The numbers and size of registers varies from one processor to another. Let's discuss the registers of the 16-bit 8086 microprocessor. Accumulator register contains AL and AH registers. It's 8-bit each and can be combined as one register, AX, or 16-bit register. AL and AH registers contain low order and high order byte of work. Accumulator is also used for I/O operations. Base register contains the BL and BH registers and can be combined to be 16-bit BX register. BL and BH contains low order bytes and high order bytes. BX registers contains data pointer or base index or register indirect addressing. Count register contains CL and CH registers 8-bit each, which can be combined also as one 16-bit register called CX. Count register is used as a counter in string manipulation and shift or rotate instructions. Data register contains DL and DH registers, which are 8-bit each and can be combined also to be 16-bit register called DX. Data register is also used as a port number for I/O operations. Source index SI and destination DI 16-bit. They are used to access the memory indirectly Next is the base pointer or BP. It's a 16-bit register. It is used to access parameters and local variables in a subroutine or a procedure. Stack pointer or SP, it's 16-bit. It's a special purpose register that maintains the stack program. Code segment, CS, it's also 16 bits, points to the segment containing the currently executing machine instructions. DS or data segment, it's also 16 bits, points at the global variables. Extra segment or AS is 16 bits. 8086 program often uses ES register to gain access to segments when it is difficult to modify the other segment registers. Stack segment or SS is a 16-bit register. It points at the segment containing the stack. The stack is used to store machine state information and return addresses of subroutines, procedures, parameters, and local variables. And that will be all for this session. Thank you so much for your time. Thank you for watching. Have a nice day. Bye.